Hi, let's look at some examples of real-world expressions and adding and subtracting. So the first problem we're going to look at is actually going to be a subtraction problem. So let's look at number 6 here with Megan and her phone. Megan wants to buy a new phone. If she continues to pay for her current phone, it costs $7 per month. But to buy a new iPhone, she first has to pay $110 for the old phone to pay it off, and then she'll be paying $1 per month. What is the difference between the new phone and the current phone? Write an expression to simplify in terms of m months. So this is a difference problem, and I'm going to write an expression for the new in terms of m months, and then I'm going to write an expression for the current, and then I'm going to subtract them. So the expression for the new phone is $110, because that's what she has to pay first to be able to get a new phone, plus $1 per month. So that's 1 times m, $1 times m months. And the current phone is $7 per month, so that's 7m. So now that I did that, I'm going to be able to get rid of these parentheses. I am going to distribute the invisible 1, so 1 times each of these things is still 110. Plus 1m, or just m, right? And then to get rid of the parentheses over here, I'm going to do a keep change. So this becomes a -1 out here. So -1 times 7, I'm just subtracting 7m either way. So plus -7m. So now when I combine like terms, I'm combining the m's together, and I get 110 plus a -6m, or -6m. So there it is. There is the expression to represent the difference in price. Here's another real-world example of prices, and this time we're going to be finding a total cost. We'll be adding. So we're going to look at number 2 here. About Joel. Joel spent $28 for an internet data service and pays $14.50 per month. He spent $24.50 to join an online movie streaming site and pays $13.25 per month. Write an expression to represent the total cost for both memberships after m months. So I'm going to first write an expression for the internet service, and I'm looking to see the one that's per month, because that's the one that's going to have the variable. So $14.50 per month, that means I'm going to multiply $14.50 times the months, and means plus, and he's also paying $28. That's not per month, just $28 in general. So there's the first expression for internet. And then when I go to the streaming service, I'm going to do the same thing. I'm going to look for the one that's per month. Here's per month here. So that means the $13.25. That's what I'm multiplying by months. And then also, and he's paying $24.50. So these are our two expressions. And then we're going to add them together. So to add them together, to get rid of the parentheses, I'm distributing that invisible 1, so nothing changes. So what I did was I removed the parentheses, and then I regrouped this using the commutative property. I put the m's together first, they're in green, and I put the constants together, they are in yellow. And now I'm just going to combine like terms. So the final expression for his total cost is he's paying $27.75 per month, and he paid $52.50. So there is our combined answer. So here is another word problem to look at, and this one, the wording can be challenging, but it's actually pretty simple. I'm going to look at number 3. Nina has X coins. Clayton has 5 fewer than 6 times the number of coins that Nina has. Write an expression for the total number of coins Nina and Clayton have together. So I'm going to take what Nina has, I'm going to add it to what Clayton has. But what Clayton has is written in terms of what Nina has. So if Nina has X coins, which we don't know how many she has a certain number of coins. But we do know that Clayton has 5 fewer than 6 times the number that Nina has. So this is all just math speak. Let's start with the 6 times. So 6 times the number that Nina has. Well, the number that Nina has is X. So we're doing 6 times X. 6 times X. And then 5 fewer than that is minus 5. So there we go. And then I could worry about this subtraction. I don't really have to because it's just on the 5. So now I can just combine like terms. X and 6x is 7x minus 5 comes along. And there you go. There is the total amount that they have altogether. In number four, it talks about community gardens. So when you hear a problem like this, like the coins, I didn't draw a picture of coins. But whenever I talk about something that has a length and a width, I like to write, especially if I'm finding perimeter, I like to draw a picture. So I'm going to draw a picture of the way this is described. And I'm going to write on this picture what it says about the length and width. It says the length of each garden was 90 feet. So I'm going to put 90 feet here on my length. But each width may vary. So vary means it could be changed. It could be all different widths. Write and simplify an expression to show the perimeter of a garden. Use G to represent the width. So I don't know what the width is, but I'm going to use G as my variable for feet. So I'm going to find the perimeter. Well, perimeter goes around the outside. So if this side here is G feet, it's also G feet over here. And the length is 90 up here. So all I'm going to do to find perimeter is I'm going to add all the sides around. So that would be 90 plus G plus 90 plus G. Or I could have just added the two 90s together first, get 180, and added the G's together and get 2G. Or even better, I could have 2G plus 90, plus 180, feet. So there's an expression to represent the perimeter. And now we come to the percent problem. So this is a challenging problem in a way, or it could be really easy for you. That'd be great. But what we're going to do is we're going to write an expression to represent the amount of pasta in the new box. And we're going to use P to represent the amount of pasta already in the box. Okay? So if the original pasta has P ounces or P grams or whatever it's going with, P. Okay, the new one is 25% more than that. So to say it's 25% more means that they have, if you remember our percent problems, we would write part, percent whole, and here it's saying it's 25% more. Well, if the percent's more, the percent, then the part is how much more it is. So because whatever the percent is, the part is. Well, we don't have any numbers except for the percent. So the original is P. It's a variable. So there's lots of variables here. So I'm going to set up our percent problem, and we would say like the amount more, so we're going to call that the M, the amount more, is equal to the percent times the original. So the amount more is 0.25p. That's how much more it is, 0.25p. Now, that's not what's in this box, that's how much more is in this box. So to find the total amount in the box, the total is going to be how much was in the original plus how much more there is. And so this is our expression for how much is inside the new box. P for the amount that was in the original plus the 25% more. And this one is kind of like number 5, except it's about 1% off. So I'm going to draw it the same way. Okay. So Joe is buying a gift card, but the gift card's on sale for 15% off. If C is the original price, so it was C dollars, what is the expression represents the cost of the gift card after the discount? So we know with the discount that you're going to take the original price and then you're going to subtract the discount. So we know the original price is C. So we have to subtract the discount. Now I can't just do C minus 15% because C is money. This is how much it costs in dollars. So I need to find the discount in dollars. So when I set up my part percent whole, I remember I have the only percent I have here is 15% off. That's the same thing as a 15% discount. So that means that my part is the discount because whatever the percent is, the part is. We remember that from our previous unit. The original is C. So when I set up my percent equation, I would be like the discount equals the 15% discount times the original. So the discount is just 0.15C. So I'm going to take this amount and it's going to go right up here. So 0.15C would be the discount. When I take that away, I would get my final answer and I can leave it like this. But really, I should combine like terms. And if I combine like terms, I'm going to accept this answer. But if we combine like terms, I would be subtracting the coefficients 1 and 0.15 from each other. So I'd actually get 0.85C as my answer. And finally, when doing a perimeter problem, my suggestion is just to go around the shape and make sure that you add the side. So I like to do this. I'm working with a triangle, so I know I'm going to do side plus side plus side. And then I just go around and make sure I've gotten all 3 sides written down. I just go like, I got that one, and now I did the last one, x minus 4. Check. Okay, I got all 3 sides. And then I go about the combining like terms. And if you need to change that to subtraction, I can put my x's together. And I get 5 x's, and I add my constants together. 1 plus 1 minus 4. So 1 plus 2 minus 4 is minus 2. So then my final perimeter will be 5x minus 2. So that's my suggestion on working with perimeter is just whatever shape you're dealing with, just go through and say, okay, I have 4 sides, 1, 2, 3, 4. And then as I work my way around the shape, I just make sure that I check off all the sides. Oh, that's so messy. That I did, but you get the idea. I didn't finish this one, sorry. Okay, thanks.